Next, quick trick 5. Consider a finite set of n numbers whose average is x. A new number y is joined to this group as n plus 1th member of the group. The new average of n plus 1 numbers is now taken as z. Here we have a good observation. The difference of averages z minus x or x minus z is equal to the difference between y and x divided by n plus 1. Here we have two different cases. In case 1, consider the value y is less than the existing average x. So with reference to x, the new average value decreases. So the difference becomes x minus z, and by using this expression we can write this difference as x minus y over n plus 1. From this expression we can write z is equal to x minus y over n plus 1. Next, in case 2, consider the value y is greater than the existing average x. So with reference to x, the new average increases. Thus, the difference becomes z minus x, and again by using this statement, we can write the difference as y minus x over n plus 1. From this, the new average z can be given as x plus y minus x over n plus 1. By using this trick, if a new value is added to a group of numbers with a certain average value, then the change in average or the new average value can be calculated directly. Next, quick trick 6. Consider a finite set of n numbers whose average is x. An existing number y is removed from this group. Then the remaining numbers will be n minus 1, and the new average of these n minus 1 numbers is taken as z. Here also, just like in our previous trick, the difference of averages z minus x or x minus z is equal to the difference between y and x divided by n minus 1. Here also we have two different cases. In case 1, consider the value y is less than the existing average x. So with reference to x, the new average value increases. Thus, the difference becomes z minus x, and by using this statement, that can be given as x minus y over n minus 1. By using the above statement, the new average z can be defined as x plus x minus y over n minus 1. Next, in case 2, consider the value y is greater than the existing average x. Under such a case, with reference to x, the new average value decreases. The difference of averages becomes x minus z, and again by using this statement, it is written as y minus x over n minus 1. By using above statement, again the new average z becomes x minus y minus x over n minus 1. By using this trick, if an existing value is removed from a group whose average is given, then the change in average or the new average value can be calculated directly. Let us have a glance at these two tricks carefully. In trick 5, we are adding a number. That's why in the denominator we are getting n plus 1. To the existing group we are adding one number. Whereas in trick 6, from the existing group we are removing a number so that the denominator always becomes n minus 1. Alright, let me explain these two tricks in a more detailed manner with some example. Let us take three numbers 2, 5 and 8 and obtain their average. It is x is equal to 5 plus 2, 7 plus 8, that is 15 over 3, which is equal to 5. I am taking a group of three numbers whose average is equal to 5. Now, come to the case 1 in trick 5. Here, I am adding a number y is equal to 3 to this group. Okay, so if I am taking the average of these four numbers 2, 3, 5 and 8, obviously that average z would be less than the existing average 5. Next, come to second case. Here, I am adding a number y is equal to 7. I'm adding such a number which is greater than the existing average to the group, and I'm taking the average of 2, 5, 7 and 8. That new average would be z greater than 5. So I'm not giving you the average values, you just find it out and check the validity of these two conditions. Next, come to case 1 in trick 6. Here, I'm removing this number 2 from this group. So, that removed number is to be taken as y. Y is equal to 2. And if I'm taking the average of the remaining two numbers, that average z would be obviously greater than the existing average. In next case, remove y is equal to 8 from the group and take the average of the remaining two numbers 2 and 5, and that value would be obviously less than 5. I think everything is clear.